Hello everyone, my name is Lotfi, and in this video let's talk about the energy levels of electrons, okay? And these are the main subjects for this video, and so let's get started, okay? As you can see in the model of the simplified atom, which is very exaggerated, because if a helium atom was the size of a football stadium, for example in this picture, the nucleus would be about the size of a pencil eraser, okay, and in the middle of the stadium, okay, and moreover the electrons would be about the size of two gnats just buzzing around the stadium, okay. So yeah, the sizing is very off, okay, but it's enough and good to us or students to learn about these, how do I say it, the atom, okay. So when two atoms approach each other, okay, in a chemical reaction, okay, their nuclei are very far apart from each other, okay, and thus their nuclei don't interact, okay. So only the electrons, which are in these lines, okay, only are involved in chemical reactions, okay. So no involvement of the nucleus, okay. So an atom's electrons differ in their energy that they possess, okay. And as some of you might know, energy, okay, is the capacity to cause change, okay. For instance, by doing work, okay, or for example pulling a rock or something up a mountain, okay. But the potential energy is the opposite, okay. It is stored inside a matter, okay, maybe because of its location of that matter or the structure of that particular matter, okay, the molecular structure, okay. And as you can see in this picture, if this this rock has potential energy stored in it because it is high up a mountain, okay. And if we just if this man over here just pushes this rock, the rock will fall down, okay, and it will actually use up all that energy, to all that potential energy, and fall down and maybe destroy something that is in the crash site, okay. So yeah, that's potential energy. A better example is when the gates of the reservoirs, reservoir dam, okay, are opened, the water behind the dam, okay, goes downhill, okay, and expends all of its potential energy for turning the turbines on its way, okay. And we use that energy to make electricity, or electrical energy, that we can use, okay. So by the movement or the kinetic energy of water, we can make electrical energy, okay, by turning these turbines, okay. So when the water just moves downhill, okay, it expends all of its energy, okay. And so the water has less potential energy in the bottom of the hill than it had in the reservoir, okay. And have in mind that matter has a natural tendency to lose or go towards the, how do I say it, to the possible lowest state of energy, okay. So states of energy. Okay, like someone, take for example someone that has a lot of fireworks, okay, and he or she just uses them all, and so after a day or two, he or she has less fireworks than he or she had the day before. Okay, and have in mind that if we want to restore the potential energy, sorry about that. Okay, so if we want to get the potential energy that of the water back into it, okay, we have to elevate the water and get it in a higher location from the bottom and to the reservoir, and so we have to use all that energy that when the water was going down and use up all that energy to take it back up again. Okay, so that's how we get potential energy back. But there is another kind of potential energy which is stored inside chemical bonds. Okay, which, for example, inside an apple. Okay, when you take an apple, there is energy stored in it in the kind or shape of potential energy, which we actually break down the parts of that glucose or that food, and we gain the energy that is stored inside it. Okay, so that's how we gain energy. Okay, now let's just let go of the reservoir example and let's go inside the cell. Okay, and see how do electrons have potential energy inside them. Okay, so the electrons of an atom have potential energy due to their distance from the nucleus. Okay, and take for example this picture over here, the big ball which has a positive charge actually is, for example, the nucleus. Okay, and the little ball with the minus charge is the electron. Okay, and so as you can see, the distance that is A to B is the electric potential energy, which if we just increase the amount of this distance, we can increase the electrical potential energy that is stored inside the electrons. Okay, and so if we actually just take the electron farther, we would have to have more energy to keep it up there, okay, or in the same distance that we have. Okay, so if we just cancel the energy of the electron, okay, the electron will just tumble down and go very close to the nucleus of that atom. Okay, and unlike a continuous flow of water, changes in the potential energy of electrons can occur only in steps of fixed amount. Okay, so for example, we want to go from point A to point B. Okay, and we have to have, for example, 10 amounts of energy, okay, or something, joules or anything. Okay, but if we don't have this 10 joules and we only have, for example, 9 joules, we can't go to the B point. Okay, and so the electron can't be in the middle of A or B. Okay, for example, you want to go and buy, for example, a cracker. Okay, you have to have, for example, a dollar. I don't know how much is a cracker. Okay, you have to have, for example, $5 to buy that. Okay, if you have $4, you can't afford it, and so you can't buy it. Okay, so that's how the electron gains and loses energy. Sorry. So an electron having a certain amount of energy is like a ball on the staircase. Okay, it can't have different amounts. It can have different amounts of energy depending on which step it is on. Okay, so for example, when the ball is on the first step, it has a lower energy than the ball that is on the second or third step. Okay, so that's how it works. Okay, and as you all know, the ball can't spend much time between these steps because it's falling very fast, so you can't expect it to be in the middle or in between the steps for longer than a few seconds. Okay, or not a few seconds, less than a few seconds. Okay, so anything. Similarly, an electron's potential energy is determined by its energy levels. Okay, and as you can see in this picture, okay, all these circles around the big ball or the nucleus is all the energy levels. Okay, or actually the shells, which we will talk about in the next slide. All these shells have different energy levels. Okay, so the one that is very close to the nucleus has less potential energy stored in its electrons than the one, for example, that is the fifth electron shell, which is very farther from the nucleus. Okay, so the one that is farther has more energy. The one that is very not that far, okay, or it has very little distance from that nucleus. Okay, and as I told you, an electron's energy level is correlated with its average distance from the nucleus. Okay, and so have in mind that an electron can move from one shell to another. Okay, for example, in the previous picture, as you can see, the shells, okay, or the circles, an electron, for example, from the first circle or shell can move to the second electron shell or circle. Okay, and it can do this by gaining or losing energy. Okay, and this energy must be equal to the distance between the old shell that the electron was in and the new shell that it wants to go. Okay, so when an electron gains a right amount of energy, okay, and as shown in this picture, when it gets a right amount of energy, it goes from the shell, okay, for example, in this example is the first shell, okay, the lowest energy level, okay, from that to level that is farther from the nucleus of that how do I say it, atom. Okay, and have in mind that these electrons gain energy, okay, from the sunlight. Okay, so the photons that come from the sun, okay, or sunlight, when it shines on atoms, okay, the electrons get energized. okay, and just move to other energy levels, okay, or these shells, okay. And have in mind that this is this reaction, not reaction, this so this step is the first step of photosynthesis, or photosynthesis reaction, okay. If you don't know what photosynthesis means, we will learn about it in later videos, but you should know that photosynthesis is a process in plants that by combining water and carbon dioxide, they form food, okay. They actually turn them into food, okay. But when electrons lose energy, they fall back down to a shell closer to the nucleus, okay. So it's not like this, that the electron just gains energy and moves up and doesn't come down. That's wrong. It comes down again, okay. And so when the electron comes down, it actually just gives off the energy that was stored inside it, okay. And so this energy is usually given to the environment as heat or light, okay. And like, for example, when it's a hot summer day and the sun is just shining all the photons on everything, okay, and you go and pick something from the car, okay, and when you touch the car, it is very hot, okay, and that's because the photons of the sun are actually how do I say this? They crash into these electrons, and these electrons gain that energy, and when after a couple seconds, okay, it just the electrons just give it off, give that energy off, okay, and so that is because so the heat is because of that energy which is being given off by the electrons, and this heat can move to the air normally, and it can even move to your hand, which if you are touching the car, okay. So that was all for this video. I hope this was helpful, and if you like it, you can just like and share this video to other people so that they can gain knowledge, and so until the next video, stay safe and have happy learnings to you all.